Welcome everyone to another episode of Unscripted Coding. Today I am going to do another LeetCode problem. I'm going to do another easy one because I was trying to explain some code earlier this week and the person I was explaining to had no clue what I was talking about. So instead of mumbling my way through it, I should really work on trying to explain my thought process well. And this helps if it's a fairly easy problem. So we're going to pick a random one. Okay, let's read this problem together first. A newly designed keypad was tested, where a tester pressed a sequence of n keys one at a time. You are given a string keys pressed of length n, where key pressed I was the ith key pressed in the testing sequence, and a sorted list, release times, where release times I was the time the ith key was released. Both arrays are zero index, and the 0th key was pressed at time 0, and every subsequent key was pressed at the exact time the previous key was released. The tester wants to know the key of the key press that had the longest duration. The ith key press had a duration of release times I minus 1, and the 0th key press had a duration of release times 0. Okay. Note that the same key could have been pressed multiple times during the test, and these multiple presses of the same key may not have had the same duration. Return the key of the key press that had the longest duration. If there are multiple such key presses, return the lexicographically largest key of the key presses. Wow, that was a lot to take in. Let me just take a look here. I am just going to do a very, very quick test here first. If B greater than A, okay, good. So very quickly, I wanted to do a test where whether Python can do this lexicographically largest. So what that is short for is whether it shows up later in the ABCs. So Z is bigger than A, B is bigger than A, and good thing, Python, you can just do a comparison. Is B greater than A? Yes. Print out yes. Okay, so let's go back here and explain what's happening. There is a string of keys pressed, so A, B, C, D, E, F, G, some random number of letters. Keys pressed only contains lowercase English letters. So somebody is pressing keyboards of all these lowercase keys. They have a string of key pressed where each letter of that string is going to be one keystroke. The other thing that is happening is this release times. It's a list of numbers right here that talk about how long that key was pressed. So, for example, C is going to be 0 to 9. Okay, so it was held for 9 seconds, milliseconds, minutes, whatever. Then B is going to be held between 9 and 29. So 29 minus 9 is 20. It was held for 20, let's say, seconds. Then C is going to be 49 minus 29, so it's 20, blah, 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 blah. Okay? So, what we're trying to do is find the longest key press, and I think This is not 100% clear, but I think what it's asking for is the longest single key press. So it does consider that C can show up twice. C just gets two entries, one that was 20 seconds long and the other that was also 20 seconds long, I think. No, first one is 9 seconds. So 9 and 20 seconds. C really only gets 20 seconds because it's a longer one. You don't add those two together. So let's go through this again. You are trying to find, somebody is tapping keys on a keyboard, holding them for different lengths of time. 1 second, 10 seconds, 20 seconds. You're given a list of the keys that were pressed and the time at which they were pressed. You're trying to figure out which key was held the longest. So, I think it seems simple enough. We're going to go through and test determine the time for each key. So right now, I want to create two different variables. First, I'm going to have n equals, and let's just give us a bit more room here, length of keys pressed. That will give us how many keys were actually pressed. That gives us an index to work with. The next one is I want to see release durations. They've given us these release times, which is helpful but not directly related to what we're trying to ask for. So what I want to do is create a new list where each one is just the actual duration. So instead of 9, 29, 49, 50, you're going to get 9, 20, 21, 9, 20, 20, then 1. And what that will mean is you can just look at that list and find the largest number. If it's 20, then you know 20 is the longest time. If 20 shows up twice, then you know you got a tiebreaker between the two. Okay, so we're going to figure out we're going to loop for I in n, so that will go 0, 1, 2, 3. We're going to create release I equals release times, and they even gave us this, release times I minus. Now, we have to account, so in this case, we're going to loop through that number of keys pressed. So we have 4 keys in this first test scenario. So it'll go 0, 1, 2, 3. And we're going to go into release times and check what is 0, what is 1, what is 2. And we're going to fill out this release durations by going 29 minus 9, 49 minus 29, 50 minus 49. But we have an edge case. The very first number, we have nothing to subtract from. So we're going to put a test case. If I equals 0, release I equals, I should really use release duration, and we're going to just take that first number, release I. Then, in all other cases, we're going to subtract the number. Now, I'm just going to print release durations and see how we're doing. This is obviously going to fail. I don't even have a return statement, but see. Always good to try and catch your errors. In this case, it's a syntax. We can't just say for I in an integer. We need to say in the range of integer so that we can properly iterate through it. Okay, next one. List assignment index out of range. Why is it out of range? Okay, I am just going to say append because there is nothing in the list right now. I can't use the index 0 or 1 or 2 because there's nothing in there. So instead, I'm just going to append to the end of it. And we're going to do it this way instead. Print release durations. I must be doing something wrong here. Is it append in Python? Let's just go list append, add item to the end of the list. Okay, let me try and run that one more time. I wonder why it's giving... Oh, sorry. Output is null. The console is outputting correctly. I thought... And let me zoom back in again. I thought that my print statement returned null. It's just down here at the bottom. Okay, very good. So as I said, we wanted 9/20/21. This is exactly what we wanted. Now, for duration in release durations, we're going to do two things here. We could pick out the index, but I think it's more effective just to go through the whole list and do the comparison. So I'll walk you through this after I write this out. But for duration and release durations, and that means we're going to go 9/20/20. Do max duration equals 0. If duration is greater than max duration, max duration equals duration max key equals let's go this way instead for keys. Okay, let's try and explain this out. So, first of all, we are going to go through each of those lists as we said before. We have a list of release times, and instead we're going to create this list of actual durations instead of when it was released. For the very first step, for the very first number, so 9 here, we can't subtract a previous number because it started at 0, then it hit 9. Okay, so in this case, we just took the first number. Then for every number afterwards, we took the current index and we subtracted the previous number, the previous index. So that's why we're going release times I, that's current number, minus release times I minus 1, the previous number. And we're just going to keep adding to this list of release durations so that at the end, we're going to get 9, 20, 20, and 1. Those are the durations. Next, we're going to try and figure out what the max duration is and what key is associated with that duration. So we're going to start with an assumption that they're all going to be greater than 0. And we have an empty key. These are just placeholder variables. Then we're going to go through each number in this release duration. So we're going to use that n again to loop through every number in our 9, 20, 21 in our released durations list. So what we're going to do is do 2 tests. The first one is if the duration, so the current one, the current number is greater than what we have logged max, then we're going to replace it. So the very first number is going to be 9 seconds and the letter C. It's obviously going to beat out our nonsensical placeholder, so it's going to replace it. So our new max duration is going to be 9, and our new max key is going to be C. Then it's going to happen all over again with the next number. It's going to be 20 because the next we did durations, not times. So B was pressed for 20 seconds. It again beats the previous one, so we're going to replace this variable again. It's going to be 20 and B, and we're going to keep going and keep going. Now what's interesting is we need a second test because of this lexigraphically largest key, because when we hit C the second time, it's also going to be 20 seconds. It's going to match this max duration. And in this case, we do a test. If they're the same, if they're lower, we ignore it. If they're higher, we're going to replace it. But if they're the same, we have to do a test. And we're going to see if this new letter is lexigraphically larger. We're just going to see if it's larger than the current leader. So in this case, C is lexigraphically larger than B, so it's going to replace it, 20 and C. So I suppose I don't even have to rewrite max duration in this case because it's the same. And that is our one test case, and it worked fantastically. I think this should work every time, so I'm going to submit right now. Excellent. I think there are other ways for us to keep working on this. I think we can probably, during this calculation of the duration, embed those tests right then and there. If it's larger than the previous one, then we start logging max keys. That way we don't have to loop through 2 different lists. We only need to loop through once and make it more performant. But we're going to leave it as is. It's a simple problem right here and there, and I think always go for simple to understand rather than jam too much in here, unless you really need that performance. So hopefully that made some sense to you. It's not a very long problem. It's only 24 lines long, but we had fun building it. So I will see you next week when we do another project. Thanks for watching.